Hello and welcome to my channel. In this video, we'll discuss what warm-blooded animals are, how they maintain their body temperature, and other important details about them. So let's start. Warm-blooded animals are animals that can maintain a constant body temperature despite the surrounding temperature. The term warm-blooded animals comes from the Greek words homoios, meaning similar, and thermix, meaning heat. These animals keep their body temperature steady no matter if they're in a hot or cold environment. Warm-blooded animals are also called homeotherms, in contrast to cold-blooded animals, ectotherms. Ectothermic animals cannot control their body temperature and depend on the environment around them to do so. In other words, their body temperature fluctuates according to the surrounding temperature. If warm-blooded animals were to stop producing body heat, they would die within minutes. On the other hand, most cold-blooded animals can tolerate drops in body temperature because their metabolisms slow down when they become cold. For example, snakes move slowly in cold weather. There are some animals like turtles and tortoises that can increase their metabolism and move faster even in cold environments. They are known as poikilothermic animals since they have variable temperature and metabolic rates. It should be noted that being warm-blooded doesn't mean having a high body temperature. For example, a blue whale has a core body temperature of around 30 degrees Celsius, while a hummingbird's temperature is about 40 degrees Celsius. Warm-blooded animals generally have larger body sizes than cold-blooded animals due to their need to maintain an optimal body temperature. As a result, there are very few small warm-blooded animals. For example, the smallest mammal in the world, the bumblebee bat, weighs only 2 grams and measures 4 centimeters long. Despite being warm-blooded, it still requires a minimum amount of energy to maintain its body temperature. Warm-blooded animals are more active than cold-blooded animals and can be found worldwide. They live in various habitats ranging from deserts to tundras and are well adapted to their surroundings. For instance, polar bears living in cold regions have thick layers of fat and fur that trap heat and keep them warm. Meanwhile, desert animals such as camels and kangaroo rats have features like large ears that help them get rid of excess heat. The classification of warm-blooded animals can be divided into 3 categories based on how they regulate their body temperature: homeotherms, endotherms, and animals with rapid metabolism. Homeotherms are warm-blooded animals whose body temperature remains stable and when exposed to severe cold, they can shiver to generate body heat and increase their metabolic rate. Shivering is a rapid and involuntary muscle contraction that generates heat. If the ambient temperature rises above their preferred level, these animals can sweat, pant, or change their behavior to avoid overheating. Mammals and birds are the only groups of animals that belong to the homeotherm category. Some examples of homeotherms include humans, mice, birds, etc. The next category of warm-blooded animals are endotherms, which means animals that maintain a stable body temperature by producing heat internally through their metabolism. They can also control their body temperature through physical activities such as sweating, panting, or changing their posture to expose their bodies to sunlight or shade. Endothermy is common in species that live in cold climates as it allows them to remain active in low temperatures. Seals and penguins are good examples of animals that rely on endothermy to survive in cold environments. These animals have a thick layer of fat under their skin and feathers or fur that provides insulation and helps them retain body heat. The last category is animals with rapid metabolism. These animals are able to maintain a stable body temperature by increasing their metabolic rate, especially when they are hibernating or inactive. However, when food is scarce, they become relatively passive. Examples of animals with rapid metabolism include most reptiles, fish, amphibians, and invertebrates. These animals can increase their metabolic rate to produce enough heat to maintain a stable body temperature. However, unlike endotherms, their increased metabolism is not constant, but rather occurs only when necessary. Although warm-blooded animals are classified into these 3 categories, the majority of them belong to the homeotherm group. followed by animals with rapid metabolism and endotherms. In summary, warm-blooded animals are those that maintain a stable body temperature regardless of the surrounding environment. They play a crucial role in maintaining the balance of ecosystems around the world. One of the primary advantages of being a warm-blooded animal is that they can be active in a wide range of climates and environments. This allows them to exploit a variety of food sources and habitats that would otherwise be inaccessible to cold-blooded animals. For example, warm-blooded animals like birds and mammals can migrate long distances to find food and shelter, whereas most cold-blooded animals cannot. Being warm-blooded also allows animals to be active at different times of the day. Birds and mammals can be active during the night or day, whereas most reptiles and amphibians are limited to warmer periods of the day. This allows warm-blooded animals to exploit new food sources and reduces competition with cold-blooded animals. As we discussed earlier, warm-blooded animals are found all over the world and can survive in a variety of habitats, including deserts, forests, and grasslands. They are absent only in very extreme environments, such as deep ocean waters and Antarctica. These animals typically inhabit regions where daily temperature fluctuations are not extreme. For example, tropical rainforests, oceans, and large lakes. This is because they are highly sensitive to sudden changes in environmental temperature. A rapid drop in body temperature can lead to coma or even immediate death. On the contrary, most cold-blooded animals can tolerate drops in body temperature and extend periods of inactivity. This allows them to conserve energy during periods of food scarcity or environmental stress. Another advantage of being warm-blooded is that it allows animals to maintain a stable internal environment. This is important because many biochemical processes in the body require a specific temperature range to function properly. For example, enzymes, which are proteins that catalyze biochemical reactions, have an optimal temperature range in which they work best. When a warm-blooded animal's body temperature rises too high or too low, it can cause problems with digestion, metabolism, and reproduction. Therefore, being warm-blooded allows animals to maintain a stable internal environment despite changes in the external environment. However, there is a downside to being a warm-blooded animal. Unlike cold-blooded animals, they cannot control their body temperature passively. Warm-blooded animals must constantly expend energy to maintain their body temperature, which can be a disadvantage when food is scarce. For example, in cold climates, warm-blooded animals must eat more food to produce enough energy to maintain their body temperature. This can be challenging during winter when food is scarce. Overall, being a warm-blooded animal offers numerous advantages and disadvantages. While it allows animals to be active in a wide range of climates, be active at different times of the day, and maintain a stable internal environment, it also requires a constant expenditure of energy and can make it difficult to survive during periods of food scarcity. Despite these disadvantages, warm-blooded animals have been successful throughout history, and today they play a crucial role in maintaining the balance of ecosystems around the world. Thank you for watching the video.